Have you ever wondered what the ultimate roadmap for human progress actually looks like? Well, let's dive right into this explainer, because today we are mapping our civilization's energy future all the way out to the year 2060. We're going to combine a massive, mind-bending cosmic concept known as the Kardashev scale with a fascinating new machine learning study to see exactly where humanity is headed. Let's kick things off with a huge question. How close is humanity to becoming a true planetary civilization? I mean, it's really the ultimate test for our species. We have to ask ourselves if we genuinely have what it takes to survive our current limitations, push past our growing pains, and truly master the energy and resources of our entire home planet. To get a solid answer to that, we have to look at a grand cosmic map that was proposed back in 1964. The Kardashev scale is basically a method of measuring a civilization's technological advancement, but it bases that measurement purely on the amount of raw energy it can harness. Soviet astronomer Nikolai Kardashev realized that as any civilization grows, its energy needs just explode exponentially. So raw power consumption becomes the ultimate metric for measuring cosmic progress. Kardashev originally envisioned three awe-inspiring stages of growth. First up, a Type 1 civilization harnesses all the energy reaching its home planet from its parent star. A Type 2 civilization scales that up to capture the total energy of the star itself. Think of building massive sci-fi megastructures like Dyson spheres. And finally, a Type 3 civilization commands the total energy of an entire galaxy. It's an absolutely incredible framework that contrasts our current sort of campfire-like reality with the macro concepts of mastering the entire cosmos. Now, what brings this scale down to earth is the math. The legendary astronomer Carl Sagan later refined Kardashev's concepts into a continuous mathematical formula. He figured out that to officially unlock Type 1 status, a civilization needs to consume roughly 10 to the 16th power watts. To put that into perspective, that is an almost unfathomable amount of power. It's essentially equivalent to harnessing all the solar energy that strikes the entire Earth. So, where exactly do we sit on that grand scale right now? Brace yourselves, because we are currently sitting at just 0.7276. Yep, we haven't even made it to a whole number yet. Categorized as a Type 0 civilization, we're still largely relying on burning ancient plants and fossil fuels to keep our lights on, meaning we have a very, very long way to go before we graduate to Type 1 status. So how do we graduate, and more importantly, when? Well, that's exactly what a recent machine learning study published in the journal Scientific Reports set out to answer. Using artificial intelligence, researchers have projected our energy destiny forward to 2060, which is a milestone many of us will actually live to see. It's a brilliant attempt to predict our Kardashev progression using complex, multidimensional historical data. To do this, researchers basically fed massive amounts of global socioeconomic and climate data into advanced algorithms. By utilizing what's called a random forest machine learning model, they hunted for complex, hidden relationships within all that historical data. Then, by applying an ARIMA time series model, they were able to competently project our global energy usage decades into the future. And what the AI uncovered is pretty eye-opening. It identified 4 primary drivers that are steering our fate. Surprisingly, the heaviest contributors aren't just climate factors. They're deeply linked to our economic supply and demand limits. It really comes down to our ecological footprint, which is our demand on nature clashing with the Earth's natural biocapacity. Add in GDP and population growth, and you've got the core engine driving our cosmic progression. The model spat out a staggering projection for our near future: 887 exajoules. By 2060, global energy consumption is expected to hit that massive mark. Just to wrap your head around that voracious appetite, that represents a 50% growth in energy usage over just 40 years. Our hunger for energy is accelerating at breakneck speed, as the global economy and our population just keep expanding. But wait, here is the catch. We grow our energy by 50%, but our Kardashev score only inches up to 0.7449. Why are we seeing such a frustratingly slow upward crawl? Well, it's because the scale is logarithmic. The higher you climb, the mountain gets exponentially steeper. So if we stick to our current energy structure, we are barely making a dent on the cosmic scale. However, the researchers factored in a massive what-if that could radically alter our entire trajectory: the nuclear fusion wildcard. Nuclear fusion is the exact same process that powers the sun, and successfully harnessing it right here on Earth could provide humanity with nearly limitless, pollution-free energy. It is, quite literally, the ultimate game changer. Let's fast forward a bit to the year 2100 to really see the impact. Without fusion, our baseline trajectory leaves us stuck at roughly 0.75. But inject fusion into the model, and we leap to roughly 0.77. Now, on a logarithmic scale, that tiny decimal bump is definitely not just a rounding error. It represents a seismic explosion in human capability, very much akin to a brand new industrial revolution. Without that fusion wildcard, the researchers conclude our baseline strategy will leave us moving at a snail's pace. While the Industrial Revolution triggered incredibly rapid growth in the 1800s, we are now bumping hard against high-carbon energy limits. If 2060 doesn't usher in the dawn of a fusion era, it could take human civilization millennia, thousands of years, to drag ourselves across the finish line to finally hit that Type 1 milestone.
But here's the thing. Reaching the Kardashev limit isn't just a matter of generating enough juice. It brings us to something called the Great Transition. Advancing on this scale required surviving our own sociological and existential hurdles. The transition to a Type 1 planetary civilization is actually considered the single most dangerous period in a species' history. Why? Because our technological power radically outpaces our social maturity.
We are currently stuck in what Carl Sagan famously warned was our technological adolescence. We're in this highly precarious, high-stakes window where we possess the power to destroy ourselves completely, whether through weapons of mass destruction or ecological collapse, long before we gain the wisdom to mature and stabilize as a unified planetary society. It is the ultimate cosmic bottleneck. Impartially analyzing this friction, physicist Michio Kaku points out that we can actually see this exact struggle playing out in modern society right now. Observing global trends, he notes that modern terrorism and deep social fractures can essentially be viewed as chaotic reactions against transitioning to a tolerant, scientific Type Y society. It's a profound friction between the push for monoculturalism and the march toward a highly cooperative, scientific global society. And honestly, even if we cracked the code on nuclear fusion tomorrow and had unlimited power, we still face hard mathematical limits of exponential growth on a finite planet. Navigating the depletion of natural resources and the deep, deep frictions of societal transformation are ultimate existential roadblocks. Scientists warn that any one of these barriers could permanently trap us at Type 0 until we exhaust our planet entirely. So, while our data-driven destiny shows absolutely incredible potential, it is ultimately up to us. I want to leave you with this final thought to ponder. Will humanity survive its own adolescence to take its rightful place among the stars, or will we just remain a cosmic footnote?